So we talked about this already. So I'm going to talk about several different kinds of neurotransmitters, just so you know what they do and how they act together. The first one is acetylcholine. Acetylcholine. There you go. Acetylcholine. And basically that's a neurotransmitter that works with cognitive functioning, learning, and memory. And when you have a lack of acetylcholine, when you have a shortage of it, it could lead to diseases like Alzheimer's disease, where basically your cognitive function decreases, you're not as fast when you think, and it's become difficult to learn and remember things, right? So as people grow older, it seems like the body just generates less acetylcholine, and it slows down the brain functions there. The next one is dopamine. You might have heard this one before. And dopamine basically is a neurotransmitter that governs most of these functions, which is muscle control, voluntary movement, inhibition of involuntary movements, and control of thoughts and emotions. So you might think of dopamine as a neurotransmitter that basically says how active your brain is. Does it think a lot? Does it not think a lot? And can you control your movements? Like if you want to move, can you stop yourself and control it? And so when there's a surplus or lack of dopamine, and so you can see there's an imbalance either way, too much or too little dopamine, that could lead to some of these mental illnesses like schizophrenia, which is when your brain is overactive and it can't stop making connections. If you've seen movies like A Beautiful Mind or a lot of movies with schizophrenia, basically this schizophrenia can lead to irrational ideas, incoherent thoughts, delusions, and hallucinations. And that's basically an excess of dopamine. When there's too much of it, then basically your brain goes in overdrive and it works itself up. Compare that to Parkinson's when there's a lack of dopamine. And you can see a lot, you might know someone who has Parkinson's, their hands start shaking, their motor functions are degenerating, and they can't control their movement as much. They stutter and they can't really talk. And so that's when a lack of dopamine. The next one is serotonin. That's another neurotransmitter, and that deals with depression and sleep disorder. So when people don't have enough serotonin, they often get insomnia, they can't sleep, they stay up all night, and also they experience depression. They just can't experience happiness because of a lack of these neurotransmitters. So a lot of these drugs kind of mimic the effect of dopamine and serotonin, for example, to control and curb people's depression and moods. Okay, just two more. Norepinephrine, you might also know this as adrenaline, is another name for that, is a neurotransmitter that's in charge of alertness, agitation, and mania. So the more epinephrine you have, the more alert you become. And so that actually too much of it leads to a disorder called ADHD, attention deficit hyper disorder, where people become overly alert and they can't really focus on one thing. Or they become manic. That's another outcome of norepinephrine. The last one I'll talk about is the gamma amino butyric acid, or GABA. And this one is a neurotransmitter that works with inhibiting anxiety, fear, and worries. Right? So if you have too much or too little of it, you become too fearful or not fearful enough. For example, you might have, it might lead to OCD, obsessive compulsive disorder, which is when you're just really into repetitive behavior, really concerned about cleanliness. Orderliness is one outcome of obsessive compulsive. You think about things and worry about too much. Or phobias, you're just afraid of things too much. You're not just worrying, you're just like physically afraid of like snakes or being outdoors or being in the sun or the dark. So all these have to, you can see there's a biological basis for a lot of these mental disorders in terms of neurotransmitters. Okay, so what happens in this, after the neurotransmitters exit the cell body and bond with the receptors, there's a lot of these floating around. And just to give you a quick story is that there's a process called reuptake, which is when the axon sucks up some of the unused neurotransmitters. That's called reuptake. Some other times they're broken down for enzymes. They get digested by other enzymes, and they turn into kind of the power to build more neurotransmitters in the future. So that's what happens.